Now we're going to move on to multiplying decimals. So to multiply decimals, we also have a procedure that we need to follow. The two steps are, first, to ignore the decimals and multiply like they were normal whole numbers. And the second step is to place the decimal point in the answer. The number of decimal places in the product is the sum of the numbers of places in the factors. What? So we're about to look at some examples so you know exactly what this step 2 means. So let's look at our first example. We have 8.3 times 74.6. Because our first step tells us to multiply like they were normal whole numbers, since I have 74.6 as the larger number, as far as our amount of digits, I want to go ahead and have that number on top as I multiply. Then I'm just going to multiply like normal. We can forget that those numbers are, the decimals are even there. So 6 times 3, 18, carry our 1. 3 times 4 is 12, plus the 1 is 13, carry our next one. 3 times 7 plus 1 is going to be 22. Okay, I'm going to go ahead and put my little X here. So now I'm going to move on to my 8. 8 times 6 is 48, carry my 4. 8 times 4 is 32, plus 4 is 36, carry my 3. 8 times 7 is 56, plus 3 is 59. Now that we've multiplied everything, we can go ahead and start our addition. 8 plus 0, 8. 3 plus 8 is 11. Carry our 1. 6 plus 2 is 8, plus 1 is 9. 2 plus 9 is 11. Carry our 1. 5 plus 1 is 6. So now we're going to get to that all-important step 2. Remember, it told us that the number of decimal places in our answer, the product, is the sum of the number of places in the factors. So how many decimal places did we have in our first? 1 decimal place, right? And in our second number, how many decimal places? 1 decimal place. So that's going to be a total of 2 decimal places. Therefore, in our product, I want the answer to have 2 decimal places behind our decimal. So to do that, I'm going to have to put it between the 9 and the 1, and now I can see that the 2 numbers behind the decimal are 1 and 8. Now we're going to try a second example. Again, I'm going to go ahead and multiply like normal. Since both of these seem to have almost the same place value, it almost doesn't matter which one I put first or last because I can get rid of that 0 in front. I'm not going to. So I'm going to go ahead and multiply like normal. So 2 times 8 is 16, carry the 1, and then we have 8 times 3 is 24, plus 1 is 25, carry the 2, 0, bring down the 2, 0 again, so I'll bring down the 0. And I'm going to go ahead and bring down that last 0 as well. Now we're going to move on to the 4. 4 times 2 is 8. 4 times 3 is 12. Carry a 1. 4 times 0 is 0 plus the 1, 0 and the 0. I'm going to move on now to multiplying that 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 0 is 0. 1 times this 0 is 0. And 1 times this last 0 is also 0. Okay, now we're going to move on to that last digit. 2 times 2 we know is 4. 2 times 3 is 6. 2 times 0 is 0. 2 times 0 is 0. And 2 times 0 is, again, 0. Before I go ahead, well, I guess we can go ahead and add these. 6, 5, and 8 is 13. Carry our 1. 2 plus 2 plus 2 is 6 plus 1 is 7. 4 plus 3 plus 1 is 8. 6 plus all those zeros is zeros, more zeros, and even more zeros. So now we're going to go ahead and count our decimal places. If I look, there was 4 numbers behind the decimal in our first number. There were none in our second number. I'm just going to go ahead and put 0 decimals. So when we add that up, that's going to be 4 decimal places total. So I'm going to count for there to be 4 decimal places. I'm going to go ahead and have to place that decimal between the 6 and the 8. So now I see 4 decimal places behind the number. A lot of people want to or question what happens with those zeros in front. Nothing, we can have as many zeros in front. It's not going to change. Our actual first digit is going to be the 6 in the ones place. So this answer will be 6 and 8,736 10,000ths. Now we're going to go ahead and look at our last example here for multiplying decimals. And I have 14 hundredths times 867 thousandths. I'm just going to go ahead. Again, I like my larger number of digits in the top, and I'm going to put that smaller number of digits in the bottom. So the commutative property lets us multiply these, so let's go ahead and get to multiplying. 7 times 4 is 28, carry the 2, 26, carry another 2, 4, carry a 3, and then we're left with 3. The nice thing is we get to multiply by a 1, so we can really just write these same numbers over again. I'm not going to go ahead and multiply by the 0. I don't really need it right now. But I do need my places. Oh, before I even do that, I guess I need to go ahead and add. So we have 8, 13, carry our 1, 11, 12, carry a 1. So now we need our places. I have 3 decimal places in my top number, 2 decimal places in my bottom number, which leaves me with a total of 5 decimal places. If I go ahead and look, I'm going to put the decimal in front of this first one because I'm going to have 1, 2, 3, 4, 5 decimal places behind it, because we always want to have a leading number in our whole number space. Even if it's a 0, I'm going to go ahead and put that 0 there as well. So we end up with 0 and 12,138 100,000ths. So next we're going to see 2 special cases with multiplying. The first one is going to be multiplying numbers by very small decimals like tenths, hundredths, thousandths, 10,000ths, and so on and so on and so on. First thing we want to do is look at our numbers here. Now on our first example, we have 1/10 times 38. We end up with an answer of 3.8. 100th times 38, we end up with 38 hundredths. 1,000th times 38, we end up with 38 thousandths. And 10,000ths times 38, we end up with 10 thousandths. We should recognize a pattern here, but if we don't, one of the rules we have as we multiply decimals with small numbers is counting the number of decimal places in each of our small tenths number, and then moving the decimal point that many places to the left in the other number. So if we go back to those 4 little examples here, we had 1 decimal place. Our decimal, we know when it's not written, is going to be at the end of the number. So if I move it left 1 place, that's where I end up with a 3.8. I have 2 decimal places. If I move it 1, 2 places, the 0.38, 1, 2, 3. I move it 1, 2, 3. I have to add that extraneous 0 there. And then again, 1, 2, 3, 4. 1, 2, 3, 4. 2 extraneous zeros to give us that 38 10,000ths. So we're going to look at 3 examples together. These should be very, very quick because we're starting to see what the pattern is, and we know our 2 little steps to multiply those small numbers. So 1/10 times 14 and 605 thousandths. Doesn't matter if our second number has a decimal in it. I only care about that tenths number. So I see that there's 1 decimal place. I see where my decimal is. I'm going to move it 1 place to the left, and our answer is going to be 1.4605. On our second example, we have 100ths times that 14.605. So I count 1, 2 places. So I'm now going to move 1, 2 decimal places to the left, and we'll end up with 0.14605. And in our third example, very quickly, we can see that we have 1, 2, 3 decimal places. So we're going to move our decimal point 1, 2, 3 places to the left. We are going to need an extraneous 0 there. So we have 0.014605 for our answer. So those were our special cases with small decimal numbers. If we have special cases with small decimal numbers, then we probably have special cases with large decimal numbers, which we're about to see next. So now we're going to be again multiplying decimals, another special case with, as I said before, the large decimal numbers, these large powers of 10, like 10, 100, 1,000, 10,000, 100,000, and so on and so on and so on. So again, we should note a pattern. I have 10 times 97.34. I end up with 973.4. 100 times 97.34, 9,734. 1,000 times 97.34 is 97,340. So if we again recognize a pattern here, we should be able to identify what we're going to do next. If not, again, we have two steps that are going to help us, and here they are. To multiply any number by 10, hundreds, thousands, and so on, first step, count the number of zeros this time, not decimal places, zeros. And step 2, move the decimal point that many places to the right in the other number. So when we had small powers of 10, we did count the decimal places. Now that we have large powers of 10, we count the zeros. When we had small powers of 10, we move to the left. Since we have large powers of 10, we're moving to the right. So let's look at our 4 examples really quickly. If we look on example 1, we have 10 times 14.605. We have 1 0, so this time we're going to move it one place to the right, and we're going to end up with 146.05. On example 2, we have 100 times that same 14.605. Since there are 2 zeros, we're going to move our decimal 2 places to the right, and we end up with 1,460.5. In example 3, we have 1,000, which has 3 zeros, so it means we're going to move the decimal 3 places to the right. And we end up with 14,605. Want to make sure that looks like a comma. And in the last one, we have 10,000 times 14.605, so we count our number of zeros. There's 4. We're going to move 1, 2, 3, 4 to the right. We are going to need that extraneous 0, so we end up with 146,050. If we want to put that decimal in a 0 just so that we have a place there, we can. If we don't want to put it, that's fine too.